Okay, so as we have seen, flanges have been designed and developed to be used in a variety of applications. Each one has its own special characteristics and should be carefully selected to meet specific function requirements. The following flanges will be discussed in detail in the next couple of videos. Weld neck, as seen here, threaded, socket weld, slip-on, lap joint, reducing, blind, and orifice. In the next couple of videos, a photograph and short description will accompany each flange, as well as symbols to depict the flange as it would appear on an engineering drawings, such as piping isometrics. The first type of flange we will cover is the weld neck. So, if you are ready, then move on to the next video. The weld neck flange, as depicted in this example, is occasionally referred to as the high hub flange. It is designed to reduce high stress concentrations at the base of the flange by transferring stress to the adjoining pipe. Now, although expensive, the weld neck flange is the best designed butt weld flange available because of its inherent structural value and ease of assembly. Known for its strength and resistance to dishing, the weld neck flange is manufactured with a long tapered hub. The tapered hub is created by the gradual increase in metal thickness from the weld joint to the flange facing. The symmetrical taper transition is extremely beneficial under conditions of repeated bending caused by the line expansion, contraction, or other external forces. The following figure shows the weld neck flange drawing symbols for both single and double lines representation. Now, keep in mind, weld neck flanges are normally used in severe service applications involving high pressures, high temperatures, or even sub-zero conditions. The hole in a weld neck flange, as highlighted here, is bored to match the ID of the adjoining pipe. In other words, the thinner the wall thickness of the pipe, the larger the bore through the flange. Conversely, the thicker the wall thickness of the pipe, the smaller the bore through the flange. Because the pipe and the flange have matching inside diameters, there is little restriction to the flow. Turbulence and erosion are therefore eliminated. Now, before constructing the drawing symbols or designing the weld neck flanges, three important dimensions must be determined. These dimensions can be found on the following chart. The thumbnail image that you can see here represents the raised face weld neck flange RFWN, as well as the position of its three dimensions in the chart. The three dimensions needed are O, L, and D. The O dimension represents the flange's outside diameter. The T defines the flange's face thickness. And the L provides the length of the flange, or length through hub dimension. These three dimensions vary for each pipe size and pound rating, and must be determined before constructing the drawing symbols of each flange or designing it. Now, to find the numerical values for these dimensions of a particular flange, select the appropriate pound rating chart, which is 150, 300, 400, and so on. For example, the chart seen here is for 300 pound rating. Next, find the proper size pipe in the nominal pipe size row highlighted here in purple. Then follow the pipe size column down through the chart to determine the O, T, and L dimensions. For demonstration purposes, a 14-inch 300-pound raised face weld neck flange will have the following dimensions. O, the outside diameter, equal to 23 inch, L, the length through hub, and T, the flange face thickness as follows. Now, as an exercise for you, use the same step-by-step procedure and the following chart to determine the dimension for a 10-inch, 600-pound ratings raised face weld neck flange. You will find the O, T, and L measurements for this flange to be as follows. Recall, if you have any question, then feel free to ask us for help in the Q&A section. The slip-on flange, as in this example, has a low hub that allows the pipe to be inserted into the flange prior to welding. Available with a flat or raised face and shorter in length than a weld neck flange, the slip-on flange is used in application where short tie-ins are necessary, or where space limitations necessitate its use, and also in replacement operations when connecting pre-existing equipment. The slip-on flange does have two significant disadvantages. One, the requirement of two fillet welds, one internal and one external, to provide sufficient strength and prevent leakage. And two, a reduced lifespan, about 1/3 that of the weld neck flange. Slip-on flanges are preferred over welding neck flanges by many users because of their lower initial cost. However, the total cost after installation is not much less than the welding neck because of the additional welding involved. The following chart provides dimensions of the slip-on flange for 150-pound rating. The thumbnail image that you can see here represents a typical example of a slip-on flange and highlights the position of its 6 dimensions. In this example, the O dimension represents the flange's outside diameter. The R defines the raised face is outside diameter. The B2 provides the diameter of the flange bore. The X defines the hub is outside diameter. The C, the flange face thickness. And finally, the Y2 provides the flange's length, or length through hub dimension. These dimensions vary for each pipe size and pound rating, and must be determined before constructing the drawing symbols of each flange or designing it. Now, to find the numerical values for these dimensions of a particular flange, you will need to use the same methodology as explained in the previous video. Recall, first, select the appropriate pound rating chart, which can be 150, 300, 400, and so on. In this example, the chart corresponds to a 150-pound rating slip-on flange. Next, find the proper pipe size in the nominal pipe size column, highlighted here in purple. Then follow the pipe size row to the right through the chart to determine the various dimensions. For demonstration purposes, a 6-inch, 150-pound rating slip-on flange will have the following dimensions. Okay, finally, keep in mind that this chart, as well as charts for different pound ratings, are also available in the downloadable resource section. So go ahead and download these charts as you will need them when taking the quiz at the end of this section.